Hi everyone, my name is Arif Adalge and I'm currently studying in sixth semester of Computer Science and Engineering in RV College of Engineering, Bengaluru. And today I'm going to be demonstrating you how to make a virtual private cloud network segmentation and access a web application via a Bastion host. Moving forward, I have my co-partner as Shivam Kalgatkar. Um, and this video is uh, is co-partner with Shivam Kalgatkar and our faculty in charge for this project is Dr. Nagaraj G. Cholli, who is an associate level professor at Department of Information Science Engineering, RV College of Engineering, Bangalore. And moving forward, talking about the project. So this project will help you uh, create a VPC that you can use for servers in a production environment. To improve resiliency, what we have done is we have deployed this servers into availability zones using an auto scale feature available in AWS, and we also have utilized application load balancer for better user experience. And for additional security, we have deployed the instances or the web application, you could say, in a private subnet so that the security maintained. The servers receive requests through the load balancers, and the servers can connect to the our hosted web application via a NAT gateway. So we're gonna show you what the complete architecture in the following slide, where I'm gonna explain how actually our project works. And so let's start with it. So this you could see is our architecture as to how we are gonna deploy our resources on AWS. So starting with, we have virtual private cloud around, and in that we have two availability zones so that we have better resiliency. And within our virtual private cloud, we have created public subnets as well as the private subnets. And um, we are making use of an auto scaling feature so that there is a better resiliency and user have better user experience. And for the security purposes, what we are doing is we are deploying uh, our application within this private subnet, as you could see. So this is a security group that is marked with red rectangle. So we are going to deploy our web application within here. So what actually happens is whenever a outside host or a outside network tries to whenever outside network tries to access what is there in this server, it cannot directly access the resources present inside of this servers. So what it has to do is it has to send a request to um, uh, the Bastion host that we are going to create in public subnet. And using the NAT gateway, what it's going to do is the NAT gateway is going to allow that request to get into private subnet via our Bastion host. So it's not going to happen directly via NAT gateway. It cannot connect directly to the private subnet or the instances in the private subnet. It has to connect to a instance in a public subnet so that there is a security maintained, right? So even if there is attack happening, the attacker cannot get to know about the IP address of the server deployed in the private subnet. It has to communicate with the Bastion host that is present in the public subnet, right? So this is how we are going to provide security to our resources that are deployed in the private subnet. And we also have created a internet gateway to interact with the outside world. So what it's gonna happen is, so if there is any request from the outside world, it's gonna first come to the um, internet gateway. Then this outside request is gonna be mapped to the NAT gateway, and NAT gateway is gonna map us to the resources that are present inside our um, private subnet, right? So without any further ado, let's get started with our project. So now we're going to start our actual presentation, our actual hands-on project. So go to the AWS first and click on AWS Cloud Computing. So go to the sign in into the console. So this, as you see, is my account. So this is my user account and not the root account. You make sure that you're launching any of your instances in the user account for a better security, because root user has more powers in order to do anything. So the user account has very less power. So if there's anything wrong, so the user will not be able to do with it, and you're not gonna get large bill. Uh, so in order to build our project, so we're gonna take reference of this project. Yeah, exactly. Okay, yeah, we're good to go. So first of all, search virtual private cloud. Okay, we're gonna search virtual private cloud and click on the VPC over here, and click on the create VPC option, and then um you get to the create VPC page where you um create VPC according to your own configurations. So first, let us understand, while creating VPC, what all are our needs. So first of all, what we are gonna do is we are gonna create a VPC, and then we need two public subnets, two private subnets, a NAT gateway, right? So in the VPC menu, you could do all these things, and also including the internet gateway. So let us configure that. Let us configure the resources that we need. So I'm gonna keep the project name as my project, right? My project, my project. Okay. So, and then, so you could also create VPCs only via a manual own method, but AWS also gives you a leverage to create VPC like with some pre-built environments. So we are going to choose VPC and more, right? So as you can see over here, when you choose VPC and more, as many resources it's gonna show us, right? So when we choose VPC and more, it's gonna uh, launch us the environments like subnets that are four, and in which uh, two are public and two are private, right? So when we have created subnets, we're gonna route them to the internet outside. So without the route table, you cannot access the information inside or outside, so you'll not be able to route the traffic inside, both inbound traffic and outbound traffic as well. So we need this is our um, internet gateway. So as we spoke in the architecture, so this is our internet gateway through which our requests are gonna come inside of our virtual private cloud. If this internet gateway is not there, we'll not be able to communicate with the outside world, right? So there's this configuration as well, which is a S3 bucket. For our project, we do not need any S3 bucket. So we are gonna like disallocate this resource right? So you can uh, tag a name to your project and let the CIDR block, that is your network block, let be with the default configurations. That is, it's gonna have 16 number of network definition out of 32-bit uh, uh, network mask, right? So that we need a number of availability zones as two. As in our architecture, we need two availability zones, right? We need two number of availability zones, and number of public subnets that we need is two, and number of private subnets that we need are two. So this is because in order to increase the resiliency of our project, so that the user has a better user experience, right? And we also need NAT gateway. So this, as you can see, um, that it's gonna cost you this cost symbol that you see, that you're actually pulling resources from the AWS resources that are present in the AWS data centers, right? So we're gonna choose as we have two availability zones. We can choose one per AC. So that means we're gonna have one NAT gateway in uh, one availability zones as we discussed in this architecture. So there's one NAT gateway over here, and there's another NAT gateway over here, right? So as we said, we do not need any S3 configuration for our project. So we are gonna disallocate this resource, and there's nothing much to configure in this page. Yeah, we're done with it, and let's move forward. So as you can see over here, so AWS is gonna create you bunch of resources just within few clicks, right? So see, it's creating all the resources as we need it. So this is another issue. It's saying that we have reached the maximum number of addresses has been reached. So that means we don't have enough of elastic IPs. So we're gonna release some of the elastic IPs. So go to EC2 instances, right? So go to EC2, and here we are gonna see for elastic IPs. Yeah, this is an option over here, elastic IPs. Click on that. Okay. So what are elastic IPs? So elastic IPs are basically IP addresses that never change even when you shut down a machine, right? So even if anything happens and you restart that machine, its IP address is not gonna change, right? So it's so in a nutshell, you could say elastic IP addresses are a static IP addresses. You could say that, right? So yeah, so um we have released the like elastic IP addresses. So let's get to VPC again and configure our needs, right? Create VPC and click on VPC and more. So so let me choose my project. My 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 project. Sorry, my project. Okay. So two number of availability zones, two public subnets, two private subnets, and NAT gateways, one per AZ, and VPC endpoints. We don't need it. So we do not need any S3 gateway over here. So let's create that. So the last time we stuck here, where last time where we stuck was here, as we were, sorry, here we were not having enough number of elastic IPs. So now we can see it has allocated as elastic IPs. And now we have to wait while the NAT gateways are being activated for our project, right? So let us wait until the resources are activated, right? So it's gonna take a while. It's gonna take some time. We are still waiting for NAT gateways to be activated. They are gonna take some time. Let's wait, let's wait. Yeah, you could see over here. Now NAT gateways have been activated. So let us view our VPC and its configurations. So as you could see that all we needed is all fine. So we have two public subnets, that is public 1, public 2, two private subnets, private 1, private 2, and both of these are in different availability zones. So US East 1A is one availability zone and US East 1B is another availability zone. So you could see over here. So currently I'm in US East 1. So there are a bunch of, so there are many um, like regions, and within that there are AZs. So within an AZ there are at least three within an region there are at least three availability zones. So these availability zones are connected to each other via optical fiber, and they are placed and they are very close to each other, say like uh, 100 kilometers or so. So that if one availability zone goes down, we are still remaining with the two availability zones, and this is how we maintain high availability in AWS, right? So also we have our tables for everything, and we also have network connection. Yeah, exactly. So we, as you could see over here, we have NAT gateway in public, subnet also in um public network 1 and public network 2, and we also have internet gateway attached to our private cloud to communicate with the outside world. So all right, so let's move forward, and let's so what do we need now is we need to create an auto scaling feature, right? So let us see that in our architecture. So this is auto scaling feature that's gonna launch us these resources automatically, right? So let's do that. Let's do that. So so go to EC2, EC2, yeah. So EC2, click on that and scroll to the bottom on the left side, and you could see over here auto scaling menu, and within that there are auto scaling groups. So click on that. Sorry. So click on the auto scaling groups, hit on create auto scaling group, right? So we are gonna give name to a project. So let's say my project. Okay. So we have to create a launch template by default. Um, so it's gonna asking us to select one. I also have templates that I created for my earlier projects. So so let us go forward and create a template that is needed for this project. Okay.